Hi, I'm Mike the Pole Barn Guru, and today we're going to talk to you a little bit about design criteria and why it's important. Now, there's only roughly 7,000 building permit issuing jurisdictions in the United States. So that's just a couple. And while we have a fairly good database that we have built from building departments that we have been in contact with, so that for most places we have a pretty close idea as to what snow loads and wind loads and general accepted soil bearing pressures are, those kinds of things. But if you consider that there are 7,000 plus of these building departments, if we started dialing them today and dialed every day for a whole year to make sure that we have the current information from each one, if we could connect with them by the time we got done, it will have easily taken a whole year, and it'll be time to start all over again, because these accepted loads get changed as jurisdictions adopt newer versions of the building code or they amend the code themselves. So we end up with changes perpetually. So we have created what we call a building department questionnaire that asks for some basic information, and whether you're going to eventually invest in a Hansen Pole building, a building kit from someone else, you're going to buy a constructed building, it's handy for you to have this information so that you're assured that what you're buying actually meets the building codes and climatic conditions where your building will be erected. So on this questionnaire, it has information like what version of the code are you using. Every 3 years, there is a new version of the building codes written. So you can end up with some real changes from one edition to the another. So it's important that we know that information. What is your ground snow load? And also then flat roof snow load. Those in real life are not or rarely the same thing. The conversion from one to the other includes factors like what's the risk of your building collapsing in the event of a catastrophic storm. So how occupied is the building? How exposed is it to the wind? Is the building heated or not? Is it a slippery roof or not? So all those things impact the conversion from one to another. Now, before there was an international building code developed in 2000, the 3 model building codes just gave you a roof snow load and called it a day. Well, that's not very scientific, and the current building codes actually are scientific. However, some building departments haven't quite figured it out yet, and so you end up with cases where they want a flat roof load and a ground load to be the same. Okay, that's fine. We can roll with that, but we need to know. Now that ground snow load, if you're somewhere where they have snow, it impacts the design of your roof because drift loads have to be accounted for or should be accounted for. This oftentimes means that roof purlins closer to the peak of your roof could be larger dimension lumber, higher graded lumber spaced closer together to keep from failing in a drift. Design wind speeds. Now, in the most recent versions of the code, wind speeds are what they call V ultimate or ultimate wind speed. However, there are building departments that are using what is called VASD, which is not the same thing. It's a lower value. There's a multiplication factor between the two, but it's important that we're getting the right information for wind speed design. Wind exposure, B, C, or D. Is this a building that's relatively protected from the wind by trees, hills, or other buildings 30 feet or greater in height in all 4 directions? If so, it's an exposure B. Exposure C would be a site that is relatively open to the wind in 190-degree pi in any direction from the building site. So even though the prevailing wind may not be in the open direction, you still should be designing for exposure C, which is a 20% greater load roughly than B exposure. There's also a D exposure, which means that your site is open to, say, wind coming across the Pacific or Atlantic Ocean, or the Gulf of the Caribbean, the Great Lakes, in some cases the Mississippi River. And it's, again, about 20% greater than a C exposure. So we need to have that information. What is your generally accepted soil bearing pressure? This is going to make a huge difference in the design of the footing pads for underneath your building columns. Roughly speaking, is the easier things grow in your soil, chances are the less strength your soil has. Topsoil and sandy soils have very low strengths as compared to rocky or bedrock soil. So we need to have this information. What's your seismic zone? In very few cases does seismic ever dictate the design of your building. Usually it's going to happen in buildings with 1 or more raised wood floors. So a 2-story or 3-story building, or a building with a mezzanine, will be more affected by seismic forces than a building with a slab on grade. Buildings with large roof snow loads will be more impacted by seismic forces than a building in the deep south where snow really is not a factor. So regardless whether you're going to get a Hansen Pole building or you think you're going to get a building from somebody else, you can get this form from us for free. Get your building department to fill it out for you. It's your insurance that what you end up getting built matches or exceeds the required loads for your building. This is Mike, the Pole Barn Guru. I hope to hear you again soon on another video. Catch you later.